Hello, dear expert and editors. I'm so glad that my paper is shortlisted for T-CSVT Best Paper Award. My name is Zhang Ke. I'm an associate professor with North China Electric Power University in China. This paper is our academic achievement. When I was a visiting scholar with the University of Missouri, Columbia in USA, Professor Tony Han is my supervisor. There are 6 sections in my presentation. First, introduction. Since Alex groundbreaking victory at the ImageNet large-scale visual recognition challenge 2012, deeper and deeper things have been proposed and achieved better performance on ImageNet or other benchmark datasets, SVHN, SVHN, and SVHN. The basic idea of ResNets is that residue mapping is easy to optimize, so ResNets skips blocks of convolutional layers by using shortcut connections to form shortcut blocks. Residue networks transfer the learning problem from reaching Y, the blue line, to reaching F, the red line, and we can find the red line is simpler and easier to learn than the blue line. More and more residue network variants and architectures have been proposed, and they form a residue networks family together, such as WRN, Pre-ResNet, RIR, CRMN. If residue mapping is easier to optimize than the original mapping, maybe the residue mapping of residue mapping is easier to optimize than original residue mapping based on our original hypothesis. We proposed a novel and simple architecture called residue networks of residue networks, RoR. We add extra shortcut connections to the original ResNets level by level. Second, contribution. Maybe the simpler, the better. Also, this idea looks simple. It is effective. Our main contribution is threefold. One, RoR improves the optimization ability of ResNets by adding a few identity shortcuts. Two, RoR is suitable for other residue networks, which is an effective complement of the residue networks family. 3. We developed reasonable strategies for RoR in different datasets and achieved the new state-of-the-art results. 3. RoR architecture based on the original ResNet. First, we add a shortcut above all residue blocks, and this shortcut can be called a root shortcut. Second, we add a shortcut above each residue block group, and these 3 shortcuts are called second-level shortcuts. Finally, the shortcuts in the original residue blocks are regarded as the 5-level shortcut. We called it 3-level RoR. In order to prove the adaptability for different ResNet architecture, we built 3-level RoR based on WRN and Pre-ResNets. We can see in Figure 3 and Figure 4, RoR creates several direct paths for propagating information between different original residue blocks by adding extra shortcuts, and layers in upper blocks can propagate information to layers in lower blocks. So RoR can elevate the vanish grading problem further. Fourth, optimization of RoR. How to choose shortcut level, number of RoR. We conducted some experiments with different depths and shortcut levels. Level number should be 3. 2. How to choose identity mapping types of RoR. can investigate 3 types of projection shortcuts A, B, and C. We get the best strategies in different data size. 3. We choose 500 as the maximum Akbar number for a big promotion. 4. Overfitting can be a critical problem. Adding extra shortcuts to the original ResNets can cause the overfitting problems to even more severe. So RoR must employ a method to alleviate the overfitting problem. So we use the SD job path method in RoR. It can alleviate overfitting problem. 5th, experiments and analysis. 1. SVHN and 100 classification by RoR. We can see from tables and figures RoR can get better performance, especially RoR at SD. 2. In order to prove the versatility of RoR for other type residual networks, we built RoR-based WRN and Pre-ResNets. The experimental results show that RoR architecture can also promote optimization abilities of other residual networks. 3. We analyze how to choose the depth and width of RoR. The experimental results show that we should carefully choose suitable depth and width on each given task to achieve good results. 4. We compare the state-of-the-art methods on SVHN and 100 and SVHN, where we achieved overwhelming results. Particularly, our RoR obtained the single model errors of 3.77% on SVHN and 19.73% on SVHN, which had state-of-the-art performance on that time. First, below 400 on SVHN and 20% on SVHN. Also, we get better performance on ImageNet this side. 6. Our related works. In recent years, we did some works with RoR. 1. We proposed the pyramidal RoR network model combines RoR with the pyramidal net. PRoR achieved the lowest classification error rates were 2.96, 16.40 on SVHN and SVHN. At that time, first below 3% on SVHN and 17% on SVHN. 2. We use RoR for age and gender estimation. RoR is effective on age and gender estimation task. 3. We propose a novel method based on our attention LSTM network for fine-grained age estimation in the wild. We use RoR as backbone network, which achieve the best performance. Based on this paper and our other works, we argue that RoR not only represents a network structure such as ResNets, Pre-ResNets, but is also an effective complement to the residual network family. Now, there are 150 Google citations which show this paper have many impacts. Thank you. That's all.